Good afternoon. I will be solving Chapter 4, Problem 22 for you today that I've taken the liberty of putting right down here. Now, this problem, I'll give you a second to read it. This problem also comes with this graph up here, which is showing the acceleration. This is an acceleration graph of the car. And we can see that this car accelerates all the way up to 300 meters per second squared, where it hits the wall and then it levels off. And the problem is asking us, as you can see, to solve for the maximum force experienced by a 1,650 kilogram car. So I'm going to write down that number so that we can keep track of all of our units. So I know that the maximum acceleration, A max, is 300 meters per second, as we can see by this graph. That's the most acceleration that it experiences before the graph decreases. And I know that our mass, or M, equals 1,650 kilograms. And it wants us to solve for the maximum force experienced. Now, this maximum force, we can solve for this by Newton's second law, and the equation that goes along with Newton's second law, F max equals m times maximum acceleration, or A max. So I'll write that down for us. And I'm going to write that in red so that we can really keep track of it. So F max equals m times A max. Now you can see that we already have our m and our A max. So now it's as simple as just plugging it in and seeing what number we get. So F max equals our mass, 1,650 kilograms, times our maximum acceleration, which is 300 meters per second squared. Now I've taken the liberty of doing this math already, and when you multiply 1,650 kilograms by 300 meters per second squared, you get 495,000 kilograms times meters per second squared. Now, as a reminder, and I'll write this in red up here, 1 kilogram times 1 meter per second squared equals 1 Newton. So, if I have 495,000, oh, and I forgot a zero there. So if I have 495,000 kilograms, oh man, I missed a G there too. Kilograms times meters per second squared, that is the same thing as having 495,000 newtons, which is also the same thing as 4.95 times 10 to the 5th newtons, or if you want to bring that down to kilonewtons, that is the same thing as 495 kilonewtons. So, what we're going to do now is put this all together and get our answer. So, we know that the maximum force experienced was 495,000 newtons of force for a 1,650 kilogram vehicle traveling at 300 meters per second squared. So to write that down and to get our final answer, our F max equals 4.95 times 10 to the 5th newtons, or 495 kilonewtons, if you would like to convert that. Thank you very much. And that is the answer to the problem. Have a good evening.